like to show you how metals plastically deform through dislocation movement. So this is roughly it, except that all these atoms are moving at the same time, and that's not the case. Instead, just one row of bonds would break and reform, and that step-by-step motion would be dislocation movement. So let's take a look at that. So I've drawn a dislocation in here, and what I'd like to do is say, okay, we're going to apply these forces to it, and what will happen is a bond will break, okay, and reform as the atoms are moving over. Okay, so I've moved those atoms over, and then a bond will reform. There's a bond. Oops, we'll use appropriate color. There you go. So it's reformed. Now another bond can break, and these atoms move over. In fact, it's the moving of the atoms really that broke the bonds, and then that bond can reform, and another bond can break as these atoms here move over, and then a bond reforms. So that's the step-by-step movement of rows of bonds breaking and reforming, and I'm not sure if this is going to work, but let's take a look and see if I can animate that with the undo button. Alright, so we're going to go backwards here and see the dislocation movement in reverse. Not too bad. So we're applying a shear stress like this to the crystal, and we're going to see the step-by-step breaking and reforming of bonds. And that is how plastic deformation occurs in metals. Okay, thank you.